This question says, using the thermodynamic information in the ALEKS data tab, calculate the standard reaction entropy of the following chemical reaction. And we're given this chemical reaction here, and it says round our answer to 0 decimal places. So we do this very similarly to how you've calculated enthalpies of reaction in the past. Here we want to calculate the entropy. And the formula is very similar. Delta S naught equals the summation of N times the entropy of the products minus the summation of N times the enthalpy of the reactants. And note that this just means that it's in the standard state, and I'm not really going to go into that, but just know that in the ALEKS data tab or in your book, the enthalpies you're given are in the standard state. So it's the same thing, the summation of N of the products minus the summation of N times the reactants, or products minus reactants, just like you would calculate for enthalpy, except here we want to look up the enthalpies, not the entropies. I know those sound similarly, but their symbols are very different, delta H versus delta S. So here we do delta S naught equals the first product, which is tin, which is 51.2 joules per K, plus 2 times the second reactant, 2 because there's second product, 2 because there's 2 CO2s, so 2 times the second product, CO2, which is 213.8 joules per K, minus, now we use the first reactant, SNO2, which is, there's only one of them, so it's 49.0 joules per K. We don't multiply that by anything. I guess technically you multiply by 1, but of course then you get the same number. Plus the second reactant, which is carbon monoxide, and there are 2 of them, so 2 times 197.7 joules per K. Now, when you do that math, you find that delta S naught equals 34.4 joule per K, or, since it says round your answer to 0 decimal places, 34 joules per K, and this is the answer that ALEKS is looking for. So again, you do this similar to how you would do the entropy, and essentially here what you're doing is you're forming these things into their atoms. So basically you take these and you form them back into the atoms that made them, and then you combine those atoms to make the products. Same as entropy, except in this case we're doing it for enthalpy.